Hello everybody, my name is Mike Geig. I hope you are all doing very well today and have come ready to watch some explosions and whatnot. So today we are obviously doing this on a different day. It's Tuesday instead of the normal Monday because I wasn't here yesterday. So I appreciate those of you who could make it today, and sorry to all of those who could not make it today or are used to watching it on Mondays, who are now watching this in the recorded session. Sorry about that. We'll be back to Mondays as usual next week. So just check the schedule. Speaking of the schedule, which you can go to unity3d.com/learn/live lessons. I don't know what. 1 second. Live training here. If you come here, we have two right now. What's the fun with explosions today, and then putting it all together, cinematic explosions next week. I am adding a bunch more soon, so check back. There will be more posted here, and we'll go from there. So check back, and you will see the stuff that we have coming up. But we've got a lot of really cool stuff coming up. So yeah. Okay, real quick before I start. As always, questions, comments, concerns, what have you, feel free to follow us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch, and we're more than happy to answer questions or just talk, or you need a shoulder to cry on, whatever. We're here for you. So yeah, just go ahead and message us if you have any comments, suggestions. A lot of you have been sending me suggestions for live sessions. I certainly appreciate that. Even if I don't respond, I'm recording all of this stuff, and I have a big old spreadsheet, and so it's not like we're not listening to you. It's just yeah, we've got a bunch of stuff lined up that I just have to stop being lazy, and I have to post it, and then we'll have that ready for you. So check out the live stuff. Feel free to continue sending me some suggestions and whatnot. Now, okay, with that all said, let's talk about what I have set up here, and then we'll go ahead and start. So I have basically I have our robot lab scene, all right, which I've put a camera over here. I have a directional light, a simple orb, and then I have some planes and a cube to act as walls, basically, because there are no colliders in here. This is just, I just grabbed the model assets, so none of this has collision and whatnot. I'm just going real basic. The only reason I did this is so that I have something visual to look at. I could have very simply used a piece of terrain or plane or something like that and move stuff around on it that way. So I absolutely did not need this particular scene. I just did that so we'd have something graphical in nature. So so there you go. So yeah, you definitely don't need these assets. If you're following along, you know, it's a simple plane or a box made of several planes to have wall collision and stuff like that. Entirely up to you. But yeah, nothing on these has a rigid body or anything. They just have colliders, except for my orb, which has a rigid body. Okay, so I do want to spend a moment real quick and explain to everybody that you're going to be incredibly disappointed by this session. Okay, so basically, what you generally think an explosion is not actually what an explosion is, right? So I had a lot of people ask me, hey, where are the particle effects, the sounds, and all that stuff, right? We're not going to have any of that, because that's not really what an explosion is, right? And don't be afraid, or don't worry, I actually provide a useful infographic to explain the difference. So I know you all were hoping we would have another image, but basically, real explosions don't have fire, don't have particle effects, don't have these big roaring, booming sounds, right? They're just an explanation of force. And that's what it's all about, right? So the movies have taught you that there's fireballs and there's all this crazy stuff that happens during an explosion. But really, in a real life explosion, stuff is just sort of moved around. Sometimes there's a pop, sometimes there's not, right? Because that's not, you know, an explosion is unseen forces, right? Kinematic forces that push objects around, right? So today we are going to talk about kinematic forces. We are going to talk about real explosive forces. Now, I don't want to leave you all completely disappointed and devastated. So next week in the PIT, which is putting it together session, we're going to cover cinematic explosions, in which case we're going to have fireballs and we're going to have sound and the explosive forces that we're going to talk about today. So yes, I'm sorry if you came here expecting fireballs and stuff. No fireballs, and I do apologize. So if you're devastated and sad, I'm sorry. Feel free to complain about it to me on Twitter, or cry or whatever. But what I'm going to show you is real physical interactions, and then next week we can get to fireballs and stuff like that. I would have loved to have done it in one session, but we tried to keep these to just 1 hour, and so I couldn't have put it all together in the amount of time. So anyway, I figured this is probably the best drawing I've ever done, and I figured that would make up for the fact that we don't get fireball explosions today. So yeah, anyway. So next week, like I said, the PIT, putting it together, is something new I've kind of introduced, where we take a bunch of concepts and we put it together to build bigger things, right? Oh, yeah, I forgot that was on there. It says, "Get well soon, Christina." Christina is one of our social media experts who, when I was drawing this today, told me she wasn't feeling good, so I put that on there. Yeah, whoops. Anyway, well, oh well. There's a missing O in my drawing. I do not know. Anyway, yeah, whatever. Yeah, right. Okay, so, anyway, done with the drawing. There you go. It's going away. I'll post it on Twitter later, and, yeah, okay, that makes sense. The missing O and pop would make it poop. We're so funny. I'm so glad you're all so mature and able to maturely handle all of this video game stuff. Okay, so I'll post that picture to Twitter later if you guys want to see it again. But let's talk real quick about what makes all of this possible. And we're going to kind of build on this. So it's going to start a little slow, but trust me, by the end of it, we're going to do some really cool stuff. So basically what makes all of this stuff possible is this rigid body component, which I have here in my sphere, right over here. And the rigid body component is what enables forces to be applied to our objects. And we have these things that, generally speaking, everyone just throws rigid bodies on stuff and just sort of forgets about it, right? But there are some really important things in here. The first is the mass, and we're going to be dealing with forces, and mass is a really big deal, all right? Because I believe force is change in velocity divided by mass times, I don't know, it has to do, basically, mass is going to cut into the amount of velocity change over time with forces, right? I don't remember the exact equation, whatever. But basically, the higher the mass, the more force will be required to get something going, right? Force, mass times acceleration. Thank you. And acceleration being a component of time. I knew time was in there somewhere. But yeah, anyway. C equals mc squared and all that jazz. I don't know. I don't remember any of that stuff. Then we have drag. And drag is basically how much force is wasted in getting something to move, all right? Then we have angular drag, which is how much force is wasted in getting something to rotate, and so on and so forth. We have this use gravity, which we'll leave on for now, and then we have is kinematic. Checking is kinematic basically turns off all built-in physics and allows us to do our own stuff. And then we have this stuff down here, which we're not going to talk about because we can do constraints and how it interpolates and all that crap. So I'm just going to basically leave that stuff alone because it's more or less completely irrelevant right now. So the rigid body is basically what makes this stuff possible, all right? And so let's talk about, basically what I'm going to do is I'm going to start with just some very basic forces, and we're going to kind of build on it from there. So the very first thing I want to do is I'm going to create myself a script, and I'm going to call this poke script. Again, I'll apologize for my loud keyboard. You all don't seem to mind every time I mention it, but I feel the need to apologize for it. So I created this poke script, which I have these other things still open here. poke script, which is basically going to allow me to use the mouse to sort of prod at this orb or whatever object I put it on. And I'm going to get rid of all this garbage in here. Someone thankfully sent me instructions on how to fix the default script, and I just haven't done it yet, so I still get this default that I always have to fix. But basically I'm going to say void on mouse down. Oh, I'm going to make this bigger too, because you guys can't see it. There we go. Void on mouse down. And yep, thank you. Did zoom in there. And basically what I'm saying is whenever I click the mouse, we're going to do something. And since this has a rigid body, since what I'm going to put this on has a rigid body, I'm going to say rigid body.add force. And the force is going to be a new vector 3. And I'm going to pass in 0, 0, 5. And we'll talk about all this stuff. But this is just a very basic thing right now. So when I click on this orb, it is going to send 5 units of force. And that's going to be used to move the orb. Alright, and so I'm going to click and drag this poke script onto the orb. There we go. And I'm going to run my scene. Alright, and if I click it, you'll notice that it starts to move. If I keep clicking it more and more and more, right, then it starts to move more and more and more, but really, right, it takes a while to get it to move. Alright, and that's because we are dealing with simple force over time, right? And so if I wanted to, and let me do this real quick. Let me go public float force, and I will instead just replace this 5 with force, so that inside the inspector we can change that. So all I did is public float force, and just the Z component is the force there. Now I can change this inside the inspector, and I'm going to make this force, this time I'm going to make it 50, alright, and I'll hit play, and now you can see it move, starts moving a lot faster. And if I wanted more force, I could say 200 and hit play. And now we're really moving along. Okay, so all we're doing is we're adding basic force to this object, right? Now, force, as in the most basic of force, is affected by mass. So if the mass of my object was 100, all right, and I click, you're going to see it's barely going to move again, right? Basically, we have 200 force, but the mass is so massive that 200 force really doesn't mean anything, right? And so force at its base is affected by the mass of our objects, and we're going to see different ways we can work with that. I can make my mass lower, as someone was pointing out. I don't know what 0 does. It has to have some mass, so it just makes it really small. But yeah, it's so small, when I click it, it goes flying. Now, someone in chat is asking, is 100 equal to 100 kilograms? I don't know. I believe they're arbitrary units. I don't know. Unity doesn't really deal with specific real-world units, so we're just talking about 100 units of mass. It's basically to say that if a feather is 1, then a car might be 2,000. And they're just relational to each other, right? That doesn't necessarily mean the feather is 1 pound and the car is 1 whatever, but it's basically just some form of relationship between them. Yeah, so anyway, I'll set this back to 1. All right, so we have basically this way to add force. We could just simply change the velocity, right? Because that's, I mean, even without forces, we could do, you know, rigid body dot velocity equals new, but that's just setting basically the directional speed of our object, and that's not really what we want either, so we're not going to bother with that. So we have this force, and that's all well and good, but you know, that's kind of boring, right? We saw it. It was just sort of this little push, and, you know, that's not really explosion-y, right? Because force has a time component to it. Oh, also, by the way, when working with add force and stuff like that, we really should be dealing with fixed update instead of regular update. And I'll talk a little later about why I don't, but really you should. So we have this add force. Now, we have these things called force modes. And force modes enable us to, and let's see here, I'm trying to scroll through here to see the different types. Come on, monodevelop. So apparently monodevelop does not allow me to scroll through. What? There we go. I can use up and down. So there's a couple ways we can use this. We can just pass in a vector 3, which is what we did already. We could pass in a vector 3 into force mode, which is what we're about to do. we can specify just the X, Y, and Z components, and then we can do the same with force mode. So just so you can see the different ways this can be used. So what I'm going to do is I'm going to type in force mode, and to show you there are 4 force modes we can use when dealing with force. The default is just force. Okay, that's what we saw. That's force over time. It's affected by mass. The one we're going to use more is impulse. Impulse basically is where all of our force happens all up front without the time component. So imagine, if you will, pushing a ball with 5 pounds from a stationary hand position. So you put your hand on a ball and then you push with 5 pounds of force and the ball will move a little bit. Now imagine moving your hand before you get to the ball, still with 5 pounds of force, but striking the ball because your hand is already in motion. And then you have what's called impulse force. Alright, so impulse force is an immediate force without the time component. And you're going to see the impulse force is much more explodey than regular force, because we're not pushing anything that we want to do. One of the questions, is there a code that is add impulse force? No, we're just going to use add force with force mode impulse. That's going to do what we want to do. And so this force is front loaded. It's all up front, no time component. Okay, so I'll go ahead and save this and come back to Unity. Now, we are definitely going to want this not to be 200. So this was 200 when we were doing with regular force. And you'll see, if I leave it as 200, boom! Alright, we just kicked that sucker right out of here. So with impulse force, we really need to reduce the amount of force we use. Even 5 is going to be a pretty good number. Because there's no time component. It is all up front. Right? So even 5 gets that thing moving pretty fast. If I were to do like 20... you would see a really good hit, boom, right? And what's really kind of neat about it, I don't know if you can see it on your screen, but I can see it on mine, is the orb actually slides a little bit before it starts to roll, because it was hit so hard that it hasn't had a chance to overcome its angular drag yet and start rolling, right? So you get a nice little slide to it, and then it rolls and stops over there where I have another collider. So impulse force, really cool. That's much more explodey than we're used to. Now, impulse force is still affected by an object's mass. Alright, so if I set that back to 100 for its mass, our impulse force is really not going to be as great as it could have been. Alright, so both force and impulse force are affected by mass. We have 2 more force modes that I don't really use all that often, but I want you to be aware of them. And so what we have is acceleration. And acceleration is basically like force. It happens over time, but it ignores mass. Alright? So mass is completely taken out of it, and it's just a change in velocity over time without any mass. And then we also have velocity change, which is like impulse, only it ignores mass. Okay, so force and impulse use mass, acceleration and velocity change do not. So those are the 4 types. And we will basically leave this as impulse. There we go. And I'll go ahead and save this. I could do force as what Napster, NPSTR says. I could use force mode as a public variable, but I'm going to leave it as impulse from now on, so I don't really need to worry about it. So we have this ability now that whenever we click the ball, it's being pushed, and so we're just basically kicking it, and that's all kind of cool. That's all nice and everything, except you'll notice that no matter where we click the ball, it always kind of goes the same way, right? So the position of the impact doesn't really matter. So now what we're going to do is we're going to modify this so that our impact happens from an appropriate direction. Okay? And so now what we're going to do is we are going to raycast from the screen to where we click. So I'm going to pull up my script again here. And now I'm going to say, on mouse down, all right, I'm going to say ray, I'm creating a ray, which is going to be equal to camera dot main dot screen to point to ray. Now I'm going to go a little bit closer, or I'm going to go a little bit faster with the coding. This is recorded. You can always go back and see this code again. Because I got to keep things kind of moving here. So just so you're aware. And basically, we're just going to make the screen point at input dot mouse position. So that's going to allow us to keep or cast array, and I'm going to create a variable that's array cast hit, call it hit, just like that. All right. And then so what I'm basically doing is from the ray, I'm just going, whenever I click to wherever the mouse is pointing, I'm casting a ray. And if that ray hits the orb, right, it's going to find out where it hit the orb, and we're going to add our force there. Okay, so what I'm going to do is, so now I have my hit, I'm actually just going to cast array. So I'm going to say if physics.raycast, there we go, and oops, and I'm going to pass in my array. Oh, I have caps lock on, that's no good. I'm going to pass in my array, I'm going to pass in out hit, and a distance of 100. That'll return true if it hits anything. Alright, so now what we're effectively doing is we are going to add forces, all right, at the point hit. And to do that, we're not going to use rigidbody.addForce. We are going to do, and let me space this out. We're going to say rigidbody.addForce at position. Okay, add force at position. So someone asked why 100. 100 is arbitrary. It's far enough out that I'll definitely hit the orb. Well, it's just an arbitrary random number. Doesn't really matter. If I did any closer, it might not be far enough to hit the orb, so I just use 100. I could do 1,000, I could do 5, I could do 10. It doesn't really matter, as long as it's long enough to actually hit. And so now I'm doing rigid body, add force at position, and again I'm just doing my vector 3 here, and instead of just my force mode, alright, I'm also going to pass in hit.point, and that is the location of the impact, and then a comma. So now we're doing add force at position. Here's our force. This is the position where the force is added, and this is the force mode again. Alright. I could do, so someone said you could do math.infinity and it'll go forever, and I don't really want it to go forever. I mean, it doesn't really matter. This isn't like a super efficient program that I'm writing, but going forever is a bit inefficient. I don't want it to go any further than it absolutely needs to, and so I just choose 100, and I'd dial that in even more if I was using this as an actual production piece of software. But okay, so rigid body, add force at position, new vector 3, hit point, so that's where we're at, and then we're doing an impulse. And so I'll come back here and I'll hit play, and now you'll see if I click off to the side, right, we get a spin on the orb. You'll notice that instead of rolling straight back, the orb spins. Okay, now we're still pushing it straight back, and that's kind of boring, right? Because even though we're spinning it, it's still going straight back. So one more thing I'm going to do to this specific orb, right, is I want to, oh, I can try pushing under it. Someone said push under it, and that's kind of what we get, just a little, put a little English on it, little shutter there. Now what I wanted to do is I wanted to actually push relative to, so I want the force to be relative to where I push it, not just the location. And so I'm going to come back here into my code, and instead of new vector 3 force, what I'm going to do is I am going to say transform dot position minus hit.point times force. And then I gotta make it so this can all fit on the screen even though I'm zoomed in. So let's do this. There we go. So there, that'll all fit on the screen. So now what we're doing is we're just finding the vector between the two, where it hit, and the center of the orb, and we're multiplying that by force. And you'll see the result is that not only do we get the proper location, we get the proper force direction as well. Boom, sideways. And then kind of off to the side, right? So we can kick it around. Obviously, we can only push it away from us because we can't click on the other side of the ball because our camera isn't over there, right? But that's the basic idea of that. All right, so this is boring, right? I get that. But we are going to build on this now, all right, to explore some of our other forces. So what we have now is we have the ability to apply an impact force to a specific location and in a specific direction to a single object, right? And that's nice, but let's look at actually adding some explosive force, all right, which is what we're going to work on next. Okay, so let's go ahead and create a new script here. So I'm going to actually take this poke script off because we just basically want what we learned from it, not necessarily to use it in any specific way. And I'm going to create a new C# script, and I'm going to call this one explosion script. So we have a new rigid body method that we're going to use, which is called add explosion force. And add explosion force is neat because it doesn't have to be on the orb specifically. It can be kind of anywhere. And the idea is that we are going to calculate the appropriate amount and the appropriate direction automatically. It's going to do that for us so we don't have to, which allows us to have some pretty neat kind of realistic stuff. All right. One question, shouldn't the direction vector be normalized? No, because it's really not all that important. The idea is the understanding of how it works. I don't really care about accuracy and all that stuff right now. You're going to see that with our next method, we don't need to do that. And that's kind of my point. I want to show you that that's how we kind of do it, but with this, we don't need to do that. We can actually do some other cool stuff. So I'm going to go ahead and open my explosion script here. And I have explosion script, fantastic. And I'm going to get rid of start here. I'm going to do my space and jazz, just like that. And so what I basically want to do, in my explosion script, I also want a public float force again. And this time what I'm going to do is I'm going to do the same ray casting jazz. Okay, but this time I don't necessarily need to hit the orb. I can hit kind of anywhere. And so since I'm doing a lot of the same ray casting, I'm actually going to come over here and I'm just going to copy it. Yoink. Because I feel like cheating. And since this is in the update function now, we can't just run this every scene. We have to only run it when we click the mouse button. Or else every time I move the mouse, things would be flying everywhere and it'd be really hard to see what's going on. So I'm going to say if input dot get mouse button down, I'll pass in 0. Alright, so if we click the left mouse button, okay, then I'm going to raycast to where the mouse is, okay, which is just the code from the previous section. Alright, and this time I'm going to say rigidbody.add explosion force. Okay, and I'm going to pass in just the amount. I don't need to pass in a vector 3. You'll notice that I pass in a float, just the amount of force, not at all that I need a vector 3. The system is going to calculate for me the direction of the explosion, right? So all I need to be like, hey, this explosion is worth 100 force, or 5 force, or 10 force, or whatever, and it's going to do all that intermittent stuff for me. So I have to specify the force, and I have to specify where the explosion is. Now this time, the explosion is not necessarily on the surface of the orb. I can click the ground, right? Because this raycast is just going to hit any collider, and the ground is a collider. And so I can click far away from it, I can click really close to it, and it's going to calculate the force as if an explosion happened at the point where I click. If I click on the wall, if I click on the ceiling, click on the floor, wherever, right? Or I could click on the orb as well. You know, it doesn't really matter. And so the position, I'm going to say hit dot point. That's where my raycast ended up. And also think if you're making a game with like a rocket launcher, right? You raycast from the tip of the rocket launcher. When it hits a wall or something, that's where your explosion goes, right? Hit dot point. Makes it real simple. And then we have the radius of the explosion. Now the radius of the explosion is its total size, in the total radius of its spherical impact. And what that means is anything that's right on top of the explosion is going to get all of the force. And anything that's at the very end of that radius is only going to get a tiny bit of force. So the force is actually kind of tapered down across ground zero, if you will, all the way to the edge of the radius. So in this case, I'm going to say 5 for my radius, but we could do 10, 20, whatever, right? But I'm just picking 5 arbitrarily, and I'll show you how that affects it, right? So this script is done. Basically, when I click the mouse button, we're casting a ray. If the ray hits a collider, i.e. the ground, the ball, whatever, we're going to generate an explosive force for our rigid body, in this case, the orb, okay? With this force, at that point of impact, and with that radius, and it's going to do all the calculations for us. All right, so let me just go ahead and boop, come back here. I'm going to drag the explosion script onto my orb. Someone had a question, how do you keep the mouse in the center of the game? Call screen.lockCursor, and that'll do it. That'll lock your mouse in the center of the screen and then make it disappear, and you can do your own crosshairs. Okay, so we'll go ahead and run this. And now, watch, I'll click over here, and we're not going to see anything. Nothing, nothing, nothing. But actually, we're still not going to see anything, whoops, because, where's my, we have a force of 0 on here. I forgot I made it a public variable. So let's give this a force of 5. Force of 5, radius of 5. There we go. So I'll run this again. And I'll go ahead, and you'll see I'm clicking closer and closer, nothing yet. Oh, we see a little bit of movement. See a little bit of movement? Get closer. You can see it's a tiny bit of force until I get closer. Then I get real close. Oh, it's spinning it. There we go. Oh, that's right, because I'm doing a really small number there. Oh, and that's another thing too. Another thing I want to point out to you is this is still not, even though it's at explosive force, it's still force mode force. Okay, so let's fix that real quick, because that's boring. Let's come back here. We'll say 5, and let's say 0. I'll explain what this 0 is in a second. Ignore this 0 for a second. And I'm going to say force mode dot impulse. There we go. I wondered why that was such a weak explosion. And so I'll get closer. You'll see a little bit. Now if I'm right on top of it, you get a much more of an explosion. If I'm under it, I can be under it. I can juggle it. Bring it back. Move it around. So, alright, so what we get is this explosive force. Alright? And we don't have to click on the ball. I mean, I can. But we can click beside it, whatever. And it's automatically calculating the direction the force should go. Okay? And that is allowing us to work through this. If you're getting, so when someone said I have an error, use of unassigned local variable hit, make sure you have the out keyword right here. If you don't have the out keyword here, it's not going to initialize hit, and then when you do this, it's going to fail. So out keyword is required. Yeah. By what rule of is the force decreased? I do not know. I think it's linear. Test Sensei asked. I think it's linear, not 100% certain. You don't get to determine that, so I'm sure they have some physics whatever that determines that. It would make sense to me for it to be linear, assuming that there's no airflow to negate explosive impact. So that's my assumption, but that is just an assumption. Any physicists out there who want to tell me different, please feel free, because I do not know how it rolls off. Okay. So we have this. One of the questions, where can this video be watched afterwards? Check the live archives. I'll post it at the end. Okay, so we have this rigid body at explosive force. Force hit point is 0. So we have this. We have our force, which is whatever we determine in the editor. The hit point is wherever I click the mouse. 5 is the radius, and I can increase that. If I want to, like, say 50, and then it'll affect more objects. But again, the further away, the more drop off it has and stuff like that. And the bigger the radius, the slower the drop off, right? Because it's got to go from 100% to 0% across the entire array. So it's more of a gradient. And then I chose my force mode impulse here, which I don't know why it doesn't default to impulse, because impulse is an explosive force, basically. But it defaults to force mode.force, which is the boring slow, right? So I changed that to force mode impulse. Now, we have this thing right here, okay? Basically, what this is our jump factor. I don't remember the actual name for it. Let me see. What do they call it? They call it the upwards modifier. And so basically what this says is, let's pretend the explosion happened under the object. And the reason that's even a thing is just for funsies, right? This isn't a real physics thing. It's to make things look cooler. And I'll show you the difference, all right? So we have 0 here, which means that the explosion is going to take place on the exact same level of where it actually takes place. So if I click the ground, the explosion is going to be on the ground. And horizontally will be parallel with the ground, right? So let me just click here. And I'll just click here, and we see it just moves it along the ground. Right? That's all well and basic. Now, if we were to add a value to this, say 1, it's going to pretend that even though the explosion is in the spot where it is, it's going to pretend that it's also 1 unit directly underneath the object, right? the result is it's going to push the object up in the air. And the reason that's cool is because it looks cool. Everyone wants, when their explosions happen, for everything to be thrown up in the air, because that's fun, right? So by putting one here, you'll see, I'll go back to running this, you're going to notice a bit of a pop. Because even though the explosion is happening when I'm clicking, it's also treating it as if it was directly 1 unit below the sphere. It makes it pop up in the air. Like I said, that is entirely for funsies, right? That's all that is because it's not realistic. I mean, the explosion happened on the ground, right beside it, should push it directly sideways, but we can give it that bit of a pop just to make it look cool, right? So yeah, that's what that does, right? So obviously if I were to set this to something like 10, right, it would be simulated as if it was 10 units underneath, right? And it really will just kind of come straight up then, right? It'll have very little horizontal movement and mostly vertical movement. But anyway, so there you go. So that's what this last one's for, and I generally kind of leave it at 1. 1 unit of upward is kind of fun for a pop, and it sends things up in the air. Okay, so at this point we are adding an explosive force to a sphere. Okay, and that's cool. And if I want to make 2 spheres, let's say I want another sphere to explode, well, I can simply duplicate the sphere I have, right? And since both spheres have the explosion script on them, you'll see that when I click, both of them get exploded. Alright, easy enough. If my radius was bigger, it would affect both of them at the same time, but my radius is 5, so they have to be relatively close together to both be affected. But you can see that by having an object with that script on it, when I click, all this happens, right? So that's okay, right? That's just okay. The fact that each of these objects would have to have that script, and each of the objects are doing their own raycast and all this stuff, that kind of sucks, and that's really not good for performance, right? So that's really not what we want, right? What we want is we want a single explosion that's going to push all sorts of things all over the place. And so what we're going to do is we're going to write a new script that's going to enable us to do that. All right, and we're basically going to write a mass explosion script. We can put it on anything. We can put it on the camera, whatever. And having forces and negative. Yeah, what does that do? Does it suck it in? Negative. Let's say negative 15. I think it sucks it in, doesn't it? Oh no, it doesn't suck it in. It kind of depends on its position, doesn't it? Yes, it does very weird thing. It does suck it in. See? Boop, doop, doop. That's an implosion force, I guess. Yeah. One of the other questions kind of mentioned was about simulating. So Tesensei is talking about simulating other physical materials. We can do that both by modifying mass, drag, and angular drag. Like for instance, if I wanted to simulate heavy water, right? Heavy water, I don't know there's such thing as heavy water. If I wanted to simulate water, I could increase the drag, right? Which slows it down a lot more quickly. So you'll see here if I explode and then it just kind of, and then just sort of drags, right? And it's kind of dampened and stuff, and it doesn't really like to move around all that much, right? I would also increase my angular drag. So we can certainly simulate different materials, and then I can apply to it physics materials, right? And put that on there as well, and the physics materials will enable us to dictate things like how bouncy is it, what kind of friction are we dealing with, that sort of thing. And I can have different physics materials on the orbs, on the ground, and all these things, and that enables us to really simulate a lot of different characteristics. I believe in the standard assets, you go to assets, import packages, physics materials, we get things like ice, wood, metal, rubber, right, that are preset that we can put on things. At any rate, so I'm digressing now. I believe that was 0 and that was 0.05. Set these things back. Okay, so what we want to do is kind of ditch this explosion script. I mean, it's good and all, but we don't want to have to reproduce these steps every time. So now we're going to talk about something now we're going to talk about something that's going to kind of explode a bunch of things, right? And it's going to, and it'll look kind of silly for starters, but then I'll show you some other cool stuff. So let's go ahead and create a new script. And this one is going to be called Mass Explosion Script, which is just fun to say, you know? Mass Explosion Script. Yeah, I like Mass Explosion Script. It has a ring to it, you know? Mass Explosion Script. Anyway, so I'm going to go ahead and get this formatted the way I want it. Mass Explosion Script. Okay. So we have our Mass Explosion Script, and now what we're going to do is this isn't going to be on any of the orbs. I mean, it could be, but it doesn't have to be. I'm just going to put it on the camera, right? So basically what we're going to do is we're going to cast, right? Again, if we press the mouse button, but we're going to do something slightly different. So I'm going to come to my explosion script, and I'm actually just going to copy this. Yoink. Because this is all the same, right? If input.get mouse button down 0, right? Oh, by the way, the reason I don't use fixed update is because then this stops working right, and it gets really weird. So really, you should, anytime you're doing rigid body add forces, you should be using fixed update, but since I'm using mouse input, it doesn't work right. So that's why I'm not doing that. But you would want to. If you're building a game and you want actual, like, quality, right? You would want to do all that stuff. But I'm not going for quality here. I'm going for explosions. So I don't really care. So we have, when we click the mouse button, we're going to raycast. All of this is still the same. I'm going to get rid of this right here. So basically now, when we raycast, I'm actually going to size this down a little bit. There we go. Just one. When we raycast, what we want to do is we want to generate a sphere wherever I click that's going to find all of the objects so I can detonate them all at once. All right? And kind of a neat thing we could do here is since this is going to return back to us all of the objects, we could do all sorts of stuff because we could like have particle effects spawn on them. We could turn their models into ragdoll models that can break apart, and we can do all sorts of neat stuff, right? Because we're not adding the force until after we get the items, right? So there's a lot of neat things we can do in there. So from the point where I click, right, where my raycast hits the ground or an orb or when it hits anything, I'm going to create what's called an overlap sphere. All right, and that overlap sphere will enable me to collect all of the colliders that it encounters. Real quick, someone MMO asked, please explain why you should use fixed update. Fixed update happens at a fixed time set. So in your regular update, if you've ever done time.delta time, in fixed update you don't have to do that because fixed update always runs at the exact same frame rate. It's for physical stuff. But anyway, I don't want to get too off topic, so that's that. But what I'm going to do is I'm going to create a collection that will be responsible for holding colliders. And you do that by writing this. Collection, or collider, is the type with these two square brackets, which will create an array. And I'm going to call my array colliders. And I'm just going to set that equal to physics.overlapSphere. And in the overlap sphere, I'm going to say hit.point, and I'm going to say radius, which reminds me, in this script, I want to have public float force and public float radius. There we go. And I want to get rid of that. Don't know why that's there. So basically what we're going to say is from the point where we click, we're going to create a sphere of this radius, and we're going to give back all of the colliders that are intersected. Yeah. Okay. So that's what that's going to do. And then all we need to do, so now that we have all these colliders, we can go through this collection and we can do anything we want. We can spawn particles, we can play sounds, we can kill those objects, we can, I don't know, throw a cake party. It doesn't really matter. We can do whatever we want because we have all of this stuff available to us. We have their colliders, so we basically have them, those objects. We can do whatever we want with those objects. So what I'm going to do is I'm going to loop through it with a for each loop. And I'm going to say for each collider call, we'll just say C, in colliders. So this is going to loop through, and every time it loops, if you're not familiar with the for each loop, I believe we have a video on that on the Learn site. Go check it out, unity3d.com/learn, where we talk about for each loops. But we're basically looping through each individual collider in this collection of colliders. And we're going to blow up each of these colliders all together, right? Now, since we want physical interactions, the collider has to have a rigid body, right? Especially because we don't want to blow up our floor. That doesn't make sense. If we blow away the floor, then everything's going to fall into infinity, and that's no good. Our floor doesn't have a rigid body, right? But our floor does have a collider. So we want to make sure there's a rigid body on something before we attempt to blow it up. Not only can we not blow something up when it doesn't have a rigid body, but it's going to give us an error if we don't do this check. So I'm going to say if c.rigidBody equals null. If it does not have a rigid body, I'm going to type continue. And what continue is going to say is, don't exit this loop, but don't do any of the rest of the code in this loop. Just go back up to the next collider and keep going from there. So basically, if this collider doesn't have a rigid body, skip it and go on to the next. That's what that line of code says. All right. Then I'm going to say c.rigidBody dot add explosion force, and my explosion force, I'm going to pass in my force variable. I'm going to say hit.point. I'm going to say radius, and I am going to say for my upwards, I'm going to say 1, and then my force mode is going to be force mode dot impulse. Just barely couldn't make it. That'll be fine. It's a little bit off screen, but you guys get it. So basically now, what this is going to do is whenever I click, it's going to collect all of the colliders around, right? And it's going to explode them. It's going to pop them up in the air by a factor of 1, and it's going to throw them about based on the force. And the neat thing about this is it doesn't go on any specific object. This works for everything. All right. So question, could you check for anything else than a null for existing rigid body? So if it has a rigid body, then this statement will be true, right? If rigid body is true, then it's got a rigid body. Or we can check to make sure it's not null. Either one works. You can check most components that way. So now, these I've already taken the explosion script off. I'm going to grab my mass explosion script and put it right on the camera. Or I could put it on the floor or wall or one of the spheres. It doesn't matter. It just has to be in the scene. It doesn't really matter where. And I'm going to hit play. And now, when I click, nothing's going to happen because I forgot to add forces. You guys, you had one job. You had one job, which was to remind me to do this, and you dropped it. And so let's make our radius something like 20. All right. So when I click this, boom, we get an explosion. And the nice thing is the explosion that we get is not on one particular sphere. And we're not doing this a bunch of times. We're just doing this one time, and we're blowing everything up. All right, which is nice. Now that looks all right, so let's take this to the next level. So now we have our explosion script. Now it's time to start blowing stuff up, right? We got the two spheres, and that's all well and good. But let's come over here. I got my prefabs. So in this particular asset set, I guess, that I downloaded from the asset store, has all these models and stuff in it. So we have this power box, which I have actually already added a rigid body to. So I'm going to bring this into the scene, and let's have some fun with this. One moment. Building awesome. Should just write a script to do this. It would be much faster. Really shouldn't have started a 4 at the bottom. That was a mistake. There. That's pleasant. Okay. Oh, we can certainly do rigid bodies at different masses here in a second. So we have this pyramid now. All right. Beautiful. Oh, apparently not. Did I added one too many. Goodbye. There we go. Beautiful pyramid. And when I click, boom, we get a nice explosion, right? It looks much better when there's other stuff, right? Your Hollywood explosions have all this fire and stuff like that, so they look cool by nature. But real explosions aren't really explosions until there's a bunch of stuff. Boom, right? And so we can really kind of pump up the force, right? Let's do this. Let's make our radius 2, but our force 15, right? So it's going to be a very small radius. What I'm going to do is I'm just going to shoot this orb into those. Oh, maybe not. Bounce it up instead. Oh, that was kind of weak. Yeah, that sucked. Let's do this. Let's come back here and let's change that to maybe 0.5 F. So we're not super below it. And let's change our force to be 30. Yeah. Radius of 1. Okay. Oh, come on. Let me do this. Let me click on it specifically. I keep clicking on the ground. Come on now. Well, with that much force, all it wants to do is fly up in the air. No, well. It'd be much easier to put something specifically on. There we go. Specifically on the ball. There we go. That was fun. But anyway, yeah. So we can do all sorts of stuff here, right? Which is fun. This is actually why I built the colliders on the walls and in the back wall as well, so we can blow stuff up and throw it all around and everything like that. Boom. So we can create these effects like this. So now, like I was saying, that next week when we add the sounds and the particle effects and the fire and all that, this is going to be a real real cinematic explosion, but you'll understand the forces better. And this isn't just all we can do with this, right? We can actually do a lot of stuff with this overlap sphere and stuff like that. So one of the questions, there are 3 planes on the scene with a collider. Why are they not affected by the explosion? Well, I did just mention that, but I'll go over it again. They have colliders, but they have no rigid bodies, which means they are not affected by physical interactions. I further enforce that by saying this: if the collider that I find has no rigid body, ignore it. So we don't attempt to put any what do I want to say? So we don't attempt to put any force on something that doesn't have a rigid body anyway, right? So that's what that's doing. So the walls don't have rigid bodies, and thus they cannot be thrown with force, and we ensure that by putting this here. Without this line here, right, if I comment that line out, you'll see that we're still not going to blow up the floor, but we're going to get errors, right? So I click and it says missing component exception. There is no rigid body attached to the plane, which is true. There isn't one, for good reason. I would definitely not want one. So there we go. So that's why those aren't blown up. So let's look at some other stuff we can do with this. Could I make an object fall faster? I can only do that by increasing gravity. And you can increase gravity by going to File, Edit, Project Settings, Physics. And we can change what constitutes a bounce. Sleeping, we can change, where's gravity at? We can change gravity right here. So, okay, so the gravity in our Unity scene is negative 9.81. Which means that 1 unit is 1 meter, because 9.81 meters per second squared is Earth's gravitation. So that, by extrapolation, means that 1 unit in Unity is 1 meter. So there you go. Didn't know that. Now we know. So, yeah, but we can change our gravity right there. Yeah. Let's see here. How can we use explosion force to use the mesh of an object, destroy it so the box really explodes? So, right here, when I kind of mentioned this too, when I get all of these objects colliders, inside the for each loop, I could say, hey, if if c.gameObject.name equals box, right? Just kind of as an example, right? Then we can instantiate a broken box mesh that exists of a bunch of individual components, and then explode each one of those, so the box flies apart, right? The key is in the fact that we get all the colliders. We can do whatever we want with it then, right? I mean, realistically, I could do something along the lines of, I could do something to c.gameObject.name equals box. Obviously, this isn't going to work because I don't have a model to put in its place. If, there we go. Delete object. Instantiate new broken box object. Explode it. That should be in comments, right? But see, at that point, we could do that, and all of the boxes would just be obliterated, right? The key is having the collider from the overlap sphere. Then we can do whatever we want with it, right? But this is kind of like, you know, a pseudocode way that we'd go about it, but that would certainly work, right? So yeah, we could do that. That's how we ragdoll, and that's how we do all these sorts of things, is we just kind of make the model go limp and then throw it around and do all this wacky crap to it, right? And we can do that with boxes and everything like that. Okay, so what about this? Like, so let's take this one step further and say, okay, I don't want to necessarily blow up these boxes. Yeah, or I can use tags, right? Let's say I don't necessarily want to blow up these boxes. let's say I want to throw everything forward, right? Like say I just had this magic power. I was playing a game and I used my magic power, and it like a Star Wars game maybe, where I just use the Force to throw everything forward, right? So I'm not necessarily blowing it up. I'm just hurling it across the room. I could certainly do that. So check this out. So what I'm going to do. So that question, can you break it into smaller parts? I just answered that. So if you missed that, go back and watch the recorded video, because I just answered that. But let's say I want to throw everything forward, right? So in this case, I wouldn't necessarily use this explosion force. Oops. Let's say I wanted to throw everything forward, right? Let's see here. Sorry, I have a lot of questions right now. If you have something behind a wall but still in the explosion radius, would have to do a raid check to make sure the explosion does not affect them. I don't know. I do not remember. I'll test that here in just a second, Midwest. We'll see. Yeah. But anyway, so let's do this. Let's do c.rigidbody.add force. So not add explosion force, add force, and let's just do new vector 3, and let's pass in 0, 0, 1 times force, and nope, not force mode, force. I don't know why sometimes it does that. And then my force mode is impulse, right? So let's say I just want to throw everything forward, right? I can certainly do that with this, right? So let's come back to Unity now, and let's see, where is my main camera? What is my force currently at? My force is at 30. That should be sufficient. So now, if I click, boom, I throw everything forward, right? Which, I don't know, that was kind of weak. Let's get more violent than that. Let's do radius 50, and our force is 50. All right, so let's see, right? So we can blow stuff up here now. That's kind of fun. Let's make our radius smaller. Let's make our radius 2. Let's just blow away the corner. Boom, and then the rest of it falls over, right? So we can target it. Boom, boom. Boom, boom, get out of here. Get out of here. You're bothering me. Boom, boom. Right, so we can certainly do all that stuff. Let's get more violent. I like violence, so let's be violent. Right? And so boom, right? And we could add an upward component there. So let's say 0.1, 0.1f. Gotta have the f. Alright, so just a small upward component to just kind of pop it up just a little bit. Boom, boom, and just throw stuff. You'll notice that the cube I have in the back isn't very thick, so when the objects go really fast, sometimes they go through. So I lost my 2 spheres. So yeah, I can just keep clicking until they pop through. Thicker wall would fix that. Alright. Yeah, you guys like my sound effects, right? Yeah. Anyway, so let's test Midwest's question here about something getting in the way. So now I'm done kind of throwing things forward. Let's go back to my explosion. Because I honestly don't know, so let's find out. So what I'm going to do is I'm going to create a cube, create other cube, iCube, and I'm going to put you at 0, 0, 0, right there. We'll just kind of put you here, scale you a little bit. So we effectively are creating a wall. That's a pretty good wall. Put it here. It has a collider, but not a rigid body. So the explosive force will not affect that. All right. So let's come back here. And let's see. Oh, well, you're absolutely correct. So the wall does protect the objects. But if I click behind it, there's no protection, because I blow them up from behind. So yeah. So our wall does in fact protect it. I did not know that. That's kind of cool. It might also be that my radius is really low. Wait a minute, I might be wrong. My radius is low. Yeah. So let's change this back to 10. Let's change our radius to 20. I might have been wrong. Let's see. I was wrong. The wall doesn't protect you at all. I'm glad I realized that my radius was so low, or else I'd have given you all incredibly incorrect information. Yeah. But yeah, so the walls do not protect it. So you would have to raycast from the point of explosion to see what it would affect and what it doesn't. Yeah. So, sorry about that. There you go. But now you know, and knowing's half the battle. Okay. So, yeah, we can sort of blow stuff up all over the place. Boom, 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 boom. And so we'll look at how to add new effects to that later. Now, before I kind of wrap up, oh, one second. Let me read through the questions here, because I just got a bunch of them. Could dynamic. What am I checking the impact for the box? Yeah, so we could, as mentioned, we could make the effect go. If the force was so high, then we could destroy the boxes. I should create an asset containing my drawings and sound effects and put on the asset store. Yeah, that would be nice, wouldn't it? You get to hear me just make all sorts of weird little noises. Okay, so actually, Krillin asks, what if you made one of the spheres into a grenade that detonates after 3 seconds? How would you do that instead of using a mouse click? I'm glad you asked, because the very next thing I'm going to show you is how to do that. Let's see here. Okay, asked how would you visualize with the explosion with particles. That's all next week, so yep, we'll do all that next week. But for Krillin's question, I almost think you were placed here, like you're a spy or something like that, because you're right on target. Let's I have a scene already made, which I have called Explosion Space. So let's click this. I don't think we need to save any of that, so no, I will not save. So I have my explosions in space, which is basically nothing, right? One question, would these explosions perform well on mobile devices? It depends. It depends on how many objects and what mobile device and all that. Basically, mobile devices are like really stupid computers, right? So mobile device can pretty much do anything a computer can do, but it works a lot harder to do it. And so, yes, but if you have a ton of objects or you do a ton of explosions or a ton of graphics, it's really going to slow the device down, and if the device is older, then it's not going to work very well. So it's always about efficiency when dealing with mobile devices. So let's look at what I have in this scene. I've got my camera. Yay, camera. It's a little bit further back, and there's nothing on it, just nothing special about it, just a camera. I have a directional light, right? Not really doing anything. And then I have a game object, and this game object has two things on it. And I'll show you these, but I'm not really going to focus on them. Or this one anyway. First, the cylinder builder. The cylinder builder is a little script I wrote that enables us to quickly and easily build a cylinder. All right. So what I'm going to do for this is, in my prefabs for my box here, I'm just going to uncheck use gravity, because now this is space. This is my explosions in space. So I'm turning gravity off. And I'm going to come back here to my empty game object. I'm going to uncheck detonation script, or detonate script for a second, because I just want to run this. And we're just going to see what that does. What this does is this script just builds a cylinder out of blocks, right? And we can see that just sort of floating here. All right, nothing interesting there. All right, and let me pull up this script just so you can see it. I'm not going to leave it up very long. If you want to watch the recorded version of this, here's the script. You can pause it. You can look through it. All right. There's the last little bit, just quaternion.identity, and this basically builds the cylinder. So I'm not going to spend a lot of time on that because it's largely irrelevant to what we're doing. It just makes the script, or just makes the cylinder. Okay. So let's open up the detonate script, because the detonate script is where all the fun happens. All right, so what we're going to do is the detonate script, when it starts, is going to say, and it's even funny that you said the grenade detonates after 3 seconds, because my detonate script detonates after 3 seconds. So I'm pretty sure you're like some spy or an alien or something like that, and that kind of unnerves me a little bit. So under the start function here, we're calling invoke, and we're invoking our detonate function after 3 seconds, right? This is just an easy way to say, in 3 seconds, blow this sucker up. We're going to blow this mother up. So in my detonate method here, I have, again, the physics overlap sphere. Nothing new here. This is just physics overlap sphere, only this time we're doing it at the origin, 0, 0, 0. And I just shorthand that by saying vector3.0. And my radius is 10, okay? So we're generating an explosion right at the middle of this cylinder, because the 0, 0 is the dead center of the cylinder, with a radius of 10. And then we're saying for each collider, all right, none of this is new. You saw this before. And we're just adding an explosive force. And again, this is really nothing new. The force is 10. We're doing it at the origin with a radius of 10, 0 up factor with an impulse, right? And that's it. So that's our detonate script. So really not anything new there. But here, I'm going to turn it back on, and we're going to see the effect. So this is what an explosion looks like in a zero gravity environment. We got to wait 3 seconds. Wait for it. Boom, right? So we get this cool little, like, boxes flying in every simple direction, right? Completely devoid of gravity. They'll go on forever, right? And so we can create these neat explosions, right? These neat anti-gravity space things and stuff like that. And I can position it to one side or the other. Like if I were to say, I don't know, let's actually, you know what? Let me run my scene again and pause it. And where's my camera? There's my camera. So let's say we want to put it to the side. So that appears to be at negative 5.7, negative 1. So let's do this. Let's put it off to the side, right? We can come to the detonate script, and in the detonate script, I'm going to say vector 3 location. I'm just shorthanding this real quick here. I'm going to say location equals new vector 3 at negative 6, 0, 0, so that I can put location here. So I don't have to type out new vector 3 in all the spots. So we're going to blow it up to the side. And boom, right? And so we get these neat shapely explosions and stuff like that. Some aren't affected at all. Others are, right? But we can do some really cool stuff to this. Are we doing the classic C# versus JavaScript in the chat right now? I'll put this argument to rest. Learn C#. Done. C# really is better. There's a reason we use C# and not JavaScript. JavaScript's a great language, but I'm not getting into that in this video. What are you guys doing to me? All right. Yeah, I'm not talking about this right now. But yeah, so we can create neat shaped explosions and stuff like that with different particles. I could build like 1,000 little tiny spheres as opposed to just a few boxes and really get like shapes to my explosions and stuff like that. We can do all sorts of crazy cool stuff, right? So yeah, explosions are really neat. Now, and like I said before, because I'm kind of wrapping up here, explosions do not necessarily have fire and sound and all these things, right? Especially in space, there would be absolutely no sound because sound waves have to travel through matter, and there's no matter in a vacuum. But yeah, so we're not going to see these like crazy cinematic whatever. Oh god, someone just said PlayStation 4 versus Xbox One. I tell you what, Xbox One again. I'm right. Trust me on this one. Anyway, really. Oh god. Yeah. So we can do all these neat things. Next week, in the putting it all together, we are going to see how to do the particles and all that stuff. We're going to have these cinematic neat effects. But yeah. Anyway, so let's talk about what we talked about today. So basically, we started small, right? If you remember, we created the poke script, and we just sort of added small amounts of force to a sphere, which was very, very boring, right? And we learned about locations and things like that. And we learned about explosive forces and stuff like that. And then the real magic comes in when we learn about physics.overlap sphere, which allows us to get collections of objects and do whatever we want with those collections of objects. In our case, we want to blow them up, which is really fun. Yeah, but okay, so from there we looked at blowing up a bunch of objects in the scene, how to stack objects and blow them up, and we learned about forward forces, right, in case I wanted to use like Jedi force powers or whatever. And then we looked at how explosions in zero gravity look and how it enables us to see, I'll click it again because I thought it looked really cool, allow us to see the shape that explosions take, right? We can see where and how and all that stuff, which is actually really, really cool. And the smaller the objects and the more of them there are, the more you get to see what an explosion actually looks like. Yeah. So we looked at all that. So that's going to kind of wrap it up for me today. Next week, again, I just want to reiterate because I want you all to show up because it's going to be awesome. Next week we're going to do the rest of the explosion stuff, the stuff that you're used to seeing. This stuff right there, the super awesome explosion-y looking stuff, because we have some stuff that looks pretty slick. But again, I'll wrap up with this. Questions, comments, suggestions, hit us up on Twitter at Unity3D, at Mike Guy, which is me, at Will Goldstone, and at The Ant Ranch. We're always listening. We're always around. Yeah. The audio tutorial is online. I forgot to add the link. I added it today. It takes like overnight to refresh, so it will be there tomorrow. I apologize for that. I just forgot to add the link, so it will be there soon. I assure you. Thank you all for everyone who watched. Appreciate it. Hopefully you found it educational, and next week it will be even more so. So thanks everyone, and you have a fantastic day.